Hi, hello, welcome back again to Kaplan's totally free week of MCAT. Hi, hi. Wait, I missed the punchline to Teacher Ashwarya's latest joke. What? We're waiting with bated breath, Ashwarya. Tell us, what do we call a really rude tryptophan? Amino acid. Emphasis on mean. That's a good one. You know, we love science jokes around here, also known as dad jokes in certain circles or teacher jokes. But if you have any of your own terrible, punny science jokes, please, please, please give them to us. Share your wit. We love them. And you will often see us batting jokes back and forth in chat. Hi, you're back. And some of you are new. Show of hands, who's back from yesterday? Where are my kidney friends? I saw a bunch of kidney friends already. I saw some names that I knew, some people who had emailed me that I talked to since yesterday. Mackenzie, I see what you did there. Does everybody see what Teacher Mackenzie did just there? Hi. Hi, welcome back. Yes, Deidre, Yasi, Patel, Carol, Paula, Meg, Giselle. Hi. Hi, Elise. Kidney friends. I get by with a little help from my kidney friend. Hi. Hi. Oh, you guys are shouting out already. Okay. Well, hello, Max. Hello, returning Kaplan students. What about newbies? I see you already. The newbies are wanting to talk. I see you jumping in there. Shout out if you are new today to the free week of Kaplan MCAT. Hey, noobs. Hi. Welcome. We had so much fun yesterday. I'm not going to rub it in, but it was pretty cool. We did some kidney stuff. We did some study planning stuff. We had a good time. Hi. Well, welcome. We're so glad to see you. So Kaplan is doing a free week of MCAT prep. This is our favorite thing that we do. We do it a couple times a year, and it's a really big deal around here. So you can bet that every tutor that you talk to, every teacher you talk to, everyone you see on screen, we are super stoked about this week. This is what we love to do as teachers, and we get to just open up to even more students here in the free week. So we are just super about it, and we're glad that you are here. I'm looking at your poll results. I see that the vast majority of us are preparing for MCATs really soon. We're going to apply this year. Yeah, that's kind of what I was expecting, even more than yesterday, right? So that's pretty cool. Let me check out these organs. The brain, 43% for brain. I would tell you, I feel like everybody loves the brain. Nobody loves studying for psych soc. Am I right? All right, sound familiar? Hi. Well, Maliesa, I tell you what, you have fabulous taste, and I agree with you. We are great. I'll just take it. Listen, I don't have to pretend to not know. I know. Hey, Deidre, you're going to do great on Friday. I was talking earlier about Harvard study on test anxiety, and it showed that students who told themselves that they were feeling really excited anytime they started to feel nervous actually performed better on the test. It's that mind over matter, just telling yourself what to do with those chemicals that are telling you fight or flight. You can take better control of those by just saying, I'm so excited. So anytime that you start to feel nervous or overwhelmed, just remind yourself of how excited you are, and your performance will show it, because guess what? That's science. Hey, neurosurgery. That's awesome, Carol. That's awesome. I tell you what. And shout out to anybody who wants to be a pediatric neurologist. I'm always, I have a son that has been working with a pediatric neurologist since he was born. And it's just so hard to find good ones because there just aren't enough of them. So if that's you, then more power to you. It's a great field to go into, but congrats. And what are the rest of you? Who knows what they're doing? Right? We got neurosurgery. Ashwarya is going to medical school to be a Hollywood movie star. That's true. Oncology. Oh, great. Pediatrics, family medicine, emergency med, never a dull day. Ortho, another oncologist, trauma surgery. Trauma surgery, Buck, you're going to be living Grey's Anatomy. I'm so jealous. I'm so jealous. Oh, neonatal surgery. That's awesome. That's also represented on Grey's Anatomy. We discovered yesterday that that's everybody's favorite medical show. OB, Winnie, that's awesome. ER for Lillian too. Neurology for Anaga. Hey. Psychiatry for Bren. Shout out to all the social science majors out there. Hey. Wow. So many different things. Isn't this inspiring to see what everybody is wanting to study? Like, I feel like I could do this all day. I feel like I could do this all day. I love it. But we got to get started at some point. We better make it now. Welcome. That's the number one thing on the agenda. I'm supposed to welcome you to Kaplan. I hope that you do feel welcome. You are welcome here. I really cannot overemphasize how excited we all are. We love doing the free prep week. It just gives us the opportunity to do what we love to do for even more people and help even more people. And, you know, everybody studying medicine is the type of person that likes to help people, and all of your teachers are the same. So it's just a really good environment. We're so happy to have you here. My name is Allie. I am a Kaplan Plus coach here. That means that my biggest area of interest is study planning. Da-da-da. I know it doesn't sound so exciting, but it really can mean the difference between a few points and a whole lot of points. You got to make sure that you're studying in the right way, that you're not making mistakes. I mean, is anyone brave enough to admit that you have put in more study hours than you have gotten out points so far, or that at some point in your study that happened to you? I would totally tell you that happened to me. I spent a lot of hours and I kept looking for that magic number. Like, okay, if I spend this many hours today or that many, or if I take this many practice tests, and at some point you start to think, well, maybe it's just me, you know, but it's not. It's not. It really is about understanding what your task is and tailoring the way that you study to that task. Not to say that we should change the study that has been successful for us in undergrad, just that we need to make sure that we figure out how to apply that, tweak it where necessary to MCAT prep, because this is prep for application-based science. This is a prep for reasoning, for logic with science, all in a timed condition and a grueling long day. So it's really important that we make sure that we pay attention to study planning. So that's an introduction to me and what I do. And I will be not only giving a group coaching lesson at the end of all of the sessions this week, but also I will be heading up the team that works with you via email all week long. So as part of Kaplan's free week, you can get coaching and advice and help from me and my team via email all week long. You see that email pinned up top? It's consultantteacher@kaplan.com. But I hope that you also entered your email, because I will be sending out a little homework quiz and some helpful handouts, and I'm just giving my advice via email all week long, which I hope that you will take advantage of. Are any of my students who emailed last night here? There should be. We got about 50 emails between yesterday and today. Questions ranging from my favorite, study planning and resource utilization, all the way to, gosh, what else? We definitely had kidney questions, because yesterday's lesson was about kidney. We had some stuff from practice tests. So I just am so excited to see you guys. And I am very proud to say that we were all caught up to emails up to 7 p.m. So if you emailed after 7 p.m., then I haven't gotten back to you yet. But it's only because I was preparing for this lesson, you know? I got to be ready for class too. Hi. Good. Well, make sure that you enter your email, because I want all of you to also be the students who are getting email support from teachers totally free all week long. You can ask us about where you're at in your prep, what study methods will work for you, if your timeline is right for you, about questions that you're working on that you've had trouble with, about concepts. It's just anything that you think that we can help you with. If we can help you, we'll let you know, but I think we probably can. We're pretty good at helping folks. So we're going to have an overview of the MCAT. It's going to be pretty quick. We're not going to get crazy with it. You're still welcome, Sarah. We like to think we're pretty awesome too. We're not going to get crazy with the overview, but I always start with an overview, and that's because we always have people who are new. Is anybody not just new to Kaplan, but new to MCAT tonight? Like, this is your first toe dip into the chilly cold waters of the MCAT. Anybody? Anybody? I feel like we always have at least a couple. At least a couple in every one of my classes, brand new. There we go. I knew it. Hi, Ikra. Hey, Brett. Hey, noobs. Nice to see you. Nice to see you. Hi, Kavya. Arsh. Hi. Natasha. Hi, Emily. Hey, Megan. Well, this is a great week to start prepping because it's the free week with Kaplan, and we're going to be doing content instruction throughout most of the week. We'll also be doing free practice tests, and we'll also be doing our boot camp, which is where we show how to break down some of the higher difficulty questions or most commonly missed questions that you'll see on the MCAT. And that's going to combine content knowledge with strategy and with that logic and with that critical thinking application, which is what the MCAT is really, really doing. So it's going to be a great culmination at our boot camp. So make sure to be there. Oh, an incoming freshman, Becca. Listen, look at you. Man, I wish, you know what? I always tell my students, you will never be upset if you start early, but you will be upset if you wait till too late. So I'm for it. Listen, get it done early, study early, prepare, pick at it as you go, or just dive right in. I love it. Do the thing. Hey. So that's why we always start with an overview, because we always have students who are very, very new. We're not going to belabor it because it is the same overview we did yesterday. But if you have questions, feel free to ask. As those of you who have been with us know, and as you're about to find out if you haven't been with us, we do have private tutors assigned to each and every one of you. So throughout class, if you have questions, just go ahead and ask them, and a private tutor will begin a conversation with you to answer those questions for you and explain those concepts to you. So you can feel free. Don't feel like, oh, I don't know. I don't want anybody to know I don't know that. I feel embarrassed, or like, oh, I don't want to slow the lesson down. No worries. We have a private tutor so that you can move at your speed all throughout class. You don't ever have to be confused, not even for a second. Just ask, even if you think it's a silly question or a little question. Sometimes, I talked about this a good bit yesterday, sometimes we just hold on to our questions out of all different kinds of reasons, but that just really compounds itself and it snowballs. And then you get to a point where you just don't understand anymore and you're not really sure where it started or how to fix it. You just don't get it anymore. But a big way to fix that is asking questions often and early and being participatory in class. And then I don't have the chance as an online teacher to correct you unless you answer in my chat. If you answer in my chat, then I get the opportunity to say, oh, I see what you're thinking. Let's just tweak it a little bit. I see where you're going with that. I see where you're coming from, but this is what we need to change. But I can't do that to you unless you're participating in my class, because I don't know what you're thinking out there. So feel free to participate, ask questions, answer things. Even if you see someone else say the same answer, you go ahead and throw it out there too. Give us the opportunity to teach you. Yes, you specifically, not just your friends in the online classroom. So we'll do the overview, and then we'll have our MCAT channel session. MCAT channel from Kaplan is the way that we personalize our courses to our students. We don't believe that any students should have the same course schedule or the same exact homework. So we do personalized homework recommendations based on your strengths and areas of opportunity, as well as allow students to take elective lessons on any given topic at any given difficulty level. And that's very important to us. And the way that we do those elective lessons is through the MCAT channel, which we have 6 days a week, live lessons, and also 24/7 archive. But this week, except for the bootcamp and the practice test, all of your lessons are coming from our MCAT channel and our content-based lessons, because we know that that's what you especially love to start with, but it's a great thing to brush up on too as you head into test day. So good kind of for everybody. Who knows what today's lesson is about? What are we studying today? Yesterday was the kidney, our favorite bean. Get it? Bean because kidney bean, because it's shaped like kidney, the beans. It's not kidney tonight though. It is one of our high yield topics. I got a lot of questions about high yield topics actually in email, so I want to address that again too. So I talked, yes, acids and bases. I talked yesterday about high yield topics, and I got some questions like, what does that mean? Like, how do I find high yield topics? So all of our Kaplan resources will order things and prioritize things accordingly. But we also have a high yield science book, and we have badges, and we kind of illustrate like what is more high yield or other. Acids and bases definitely are going to be up there. I'm so excited that you guys are seeing there. Some other things that you might think of are just things that come up a lot on the test: cellular metabolism, cell biology, kinematics. So focus on the things that are coming up a lot, but I do have a really good tip for you, and that is this. Allow your study to tell you what your science study should be. Allow your MCAT study to tell you what your science study should be. Sometimes we want to get very deep into science study and we want to break out all our old books and learn all of the science. But guess what? Not all science is tested on the MCAT. And even the things and the topics that are tested on the MCAT are only tested so deep. Does anybody remember the phrase that I kept using yesterday for what kind of things are tested on the MCAT? Had the word deep in it. That's why it just reminded me. But instead of going straight to science books and science flashcards and memorizing science concepts, get out your MCAT practice questions and allow your performance on those practice questions to really illustrate to you not only what is coming up a lot on MCAT and in MCAT questions, but also what is that science that you're missing? Because sometimes you're missing questions that it's not science content. Sometimes it is. And you can allow the actual process of MCAT prep to lead the study of science that you're doing for the MCAT rather than just studying all things science and hoping that that will then be sufficient for the MCAT. Because the MCAT is so much more than science, and you also need to study and get time with that. So I think if you make that switch and do yes, you guys were listening, I love it. That warms my heart. It's always a mile wide and an inch deep. They do expect you to know a lot of topics, but only a little bit. So a little bit about a lot. So it's a mile wide, but it's an inch deep. So you need to know kind of what to study, but let your MCAT prep lead the way, because I'm sure that no one here is just really, really dying to relearn all of the science from undergrad, right? I think that what we're dying to do is do really, really well on our MCAT, which starts and ends and has its whole middle part with MCAT prep. So make that change in your study, and I think that you will see points more quickly. So I did want to address that. Tonight's MCAT channel session, yes, is Essence Basis. Everybody got the email, right? If you were here yesterday, did you guys do the pre-quiz? Isn't that cute, that little pre-quiz? I love it. I love analogies and putting things into like real life topics and like things that are very earthy and grounded. Have you ever seen them do that before? I had not seen that before we started doing that here at Kaplan, but I love those little quizzes. And we'll do something like that or some preview material for the next night's lesson every night this week. So yes, you got it. You did it. Awesome. I had the hardest time formatting those for you because I was like, I could send it in like a PowerPoint, but I didn't know if everybody had PowerPoint. So I was like, how do I formulate this? So I hope that you guys all figured out that like mark and highlight thing that I did. I thought that was pretty clever myself. I'm going to toot my own horn. So we're doing acids and bases. Yeah, it's not bad, Annalise, just to get you warmed up, just to get you thinking about the kind of ideas, but you will see throughout today's lesson how the kind of ideas that we highlighted there, even in the simplest ways, really come into play in today's lesson. So I'm so glad that y'all got opportunity to do that. Make sure that your email, again, is in my poll, and you will get the pre-quiz for the next night's lesson in tonight's email. Again, we're going to finish with plus coaching. Tonight's topic for plus coaching is how to build your MCAT study calendar. So we're going to talk about the things that you should avoid in your study calendaring, and we're going to talk about how to fit things in around working full-time and shadowing and volunteering and raising your family or whatever all it is, going to school, whatever all it is that you're doing, how to build a solid MCAT calendar around that. Let's see, and then Q&A. And yeah, also too, if you did not receive the email, always check your spam. Like if you entered your email and hit submit but did not receive it, always check your spam. That's always the first place. Also, if you gave like a corporate, sometimes the corporates have these things where they send back an email requiring me to prove like that I'm a human by going through all these different things, but I can't do it because I'm also at a corporation, so I can't get into the thing. So that might be a thing. So make sure that you use an email where you can get email, like maybe not your corporate, if that's a thing. Always check your spam as well. And then sometimes it's just down to like a typo. So if there's a typo, that could happen too. But you can always email me directly at consultedteacher.com and say, hey, I didn't get that one after whatever lesson. Can you send it again? And I will totally do that. I'm happy to do that. I need you to be successful. We only get to do what we do as long as you guys are successful. So it's really important to us. So we'll end today's lesson if we have time with Q&A. Otherwise, we'll handle that Q&A via email with your free email teacher support all week long. Let's talk about the MCAT. 7 hours long. The test is really long. Those of you newbies, I bet you already knew this, right? You might be super new. You might be starting today, but I bet you knew that MCAT was super long. The MCAT is the longest graduate level entrance exam out there. I mean, it's just super long. It's super grueling. It is a full day. And this is why, look at how many questions they give you. So many questions. So many. Go ahead and take a screenshot so you can have this. We're going to move on. We're going to move on to the scoring of the test. So here you see the scoring. Scoring is the same in each of the 4 sections. It makes up a total, of course, between 472 and 528 with an expected average right about 500. But that's of test takers. That's of tests taken. It's not of who gets admitted. So y'all tell me, experts, those of you who were with us yesterday should definitely get this right. But you guys tell me, what is the average admit score for medical school? What are we aiming for? What do we need to get, or at least make as a good solid goal for us as a starting point to be particularly safe to go to med school? What was it? We talked about it yesterday. I know that y'all know this. Yes. There you go. Ooh, Kat's getting extra specific. I love it. Look at all these right answers. Look at how good you guys are doing. It's like you came to Kaplan one day and now you're getting straight A's. That's kind of how it works around here, but I love to see it every time. You are correct. It's going to be about a 510. We call it a 510. Average range is 509 to 511, so 510 is really good. Does that mean that that's the average admit for your target program? Absolutely not. That could be a totally different number, but that is the average admit score across all of the schools. So we love to use that as our own particular guide. Sorry, I dropped something. Yeah, so 510 is what we're going to shoot for, but it always comes down to research. Make sure that you are doing your research into the programs that you are interested in. And that's another thing too that just goes to prep generally. You have to not only have a starting point, you got to take your practice test, but you also have to have an end goal. And if your target school is Harvard, that bare minimum score that you have to get to is very different than someone else's who is not planning to go to Harvard. You know, you have to look and see, and that goes for all schools, all schools. So make sure that you're doing that research. Moving right on. I love this screen. Go ahead and take a screenshot too. Also, those of you who are wondering more about high yield, definitely you can look here and get some insights. For example, look at all that blue. Look at all that biology. The thing that I find interesting here is just look at how mixed each of these sections are. Just look at how mixed all of the different colors are, because sometimes we get very focused on like, oh, I have to study my biochem. I have to know everything biochem. I have to know everything chemistry. I have to know everything psychology. And first of all, it's not everything. It's mile wide and an inch deep. But also, MCAT loves to put some MCAT in your MCAT. They're like, hey, I heard you love the MCAT, so I want to put some MCAT in your MCAT. And they will do that. Many of the questions will touch on multiple sciences at the same time. Yes, the same darn time. And you have to be prepared for that. So that's another reason that letting your science instruction lead the way rather than letting MCAT prep lead the way is often a very inefficient way to study, because you might end up with all of this like single science information, but then you start seeing questions where they've mixed them and you're not ready for that. And you haven't left a lot of time to now do MCAT specific prep because you did all of that science prep. So again, letting the MCAT prep lead the way and tell you what you need to do is really good. Of course, here at Kaplan, we do a science content assessment as well as a diagnostic test at the beginning of all of our courses. So we get a really clear breakdown of where your sciences are stronger and weaker and what you need to work on. And then we can check that against the yield. But this is something you can do on your own as well, but it always starts with letting that MCAT prep lead the way, because MCAT prep is very different than science prep. Good, Toya, I love it. I love it. Back me up here. I'll take it. I will take it. Of course, MCAT science skills, you guys know these are my favorites. I'm going to let you guys, those of you who have taken a practice test, seen some MCAT questions before, tell me, what was the first thing, or what was a thing, or what sticks out in your mind that you saw in an MCAT question that made you go, huh, this is not like the science test I'm used to? This is something different. When was it that you recognized that? For me, it was when I started to see the patterns in the answer choices. And I was like, huh, this is like, this is different. This is different. The passages, Bren, right? So passages bring in a whole bunch of information and you got to weed through it, find out what's relevant, what's not relevant. That's very different than just being asked rote science questions. That is so, so different. Everything. Linus was like the whole test. The whole test was like, this is not the science I know. Interpreting data, absolutely. Seeing the interconnections, all the types of sciences. Yes, a lot of research. Exactly, because Toya, what are you going to be doing in medical school? What are you going to be doing? Especially those of you trying to go MD, PhD, research is key. Definitely patterns. The linking of the different subjects, yes. Discrete questions disguised as passage-based questions. Listen, Pri, I see you. Way to think critically, absolutely. Process of elimination can be very helpful here, Hannah. Absolutely. I will tell you, the MCAT is testing something different. They're not just looking for that unicorn who knows every single science fact and understands every single thing about science already. And they'll take that person. They will absolutely take that person. And that person can get a near perfect score with very little prep. That person is a unicorn. I am not a unicorn. And since most of you are in my classroom, I'm assuming that most of us are not unicorns, and that's okay because the MCAT has also provided a way for all of us non-unicorns. They're like, well, let me see who thinks strategically. Let me leave a little strategy hint here. Let me leave a little clue. Let me leave a little pattern. Let me leave a passage with all the information that they need and see if they can make those connections because they're also looking, aside from the random unicorns, they're also looking for the regular horses out there who think strategically, who think critically, who can make solid connections and not get overwhelmed with having to do that during crunch time, because those are also people who are going to do fabulously in medical school. Extreme answers, Neha. I see you've been to our practice test. I love it. I love it. I'm glad that you guys are paying attention to this. Really learning to understand the test is your key to beating it. The students that I see who end up spending way too much time for too little points, who end up burning out as they prep, are students who often are not shown or unable to see that it's more than just a science test. If you're able to see that already, you are so far ahead of the game and you are so much less likely to waste your time, and you're going to be able to move so much more quickly towards your MCAT goals. So I'm really excited to hear that. And I love to hear all of the answers that are coming in. You guys warm my heart just a little bit. Tonight we're doing a full MCAT channel sessions. Of course it's acids and bases, but it's not with me. No. It is not with me because I am your coach for the week, and that's via email as well. Do make sure that your email is in my poll so that you can get tonight's handouts after class. You can get any relevant notes from today's teacher that he wants me to pass along. I'll make sure to pass those along too. That you can get the pre-quiz for tomorrow's lesson as well, and you can have access to me and my team to ask questions all week long. That's a totally free service from Kaplan. I'm super happy to do it as well. But now it's time for acids and bases, and with one of our most distinguished instructors. You're going to love him. He is so smart. Please soak up everything that he has to share. I feel like a little baby sponge every time I see him again because I'm soaking up so much in terms of teaching techniques, in terms of even science. He says it different, and I learn something new or understand something in a whole new way every single time. You're going to love him. His name is Teacher Petros. I'm going to pass you off now. Petros, go ahead and take over your class. They are a wonderful group, very participatory, and I will see y'all later for making your MCAT study calendar. Bye-bye.
All right. Hello, everyone, and thank you, Allie, for our intro. Hopefully, everybody's having a good evening here tonight. We're actually really lucky. We've got a full team. So we've got Ashwarya here, we've got Allison here, we've got Dee, we've got Henry, we've got Mackenzie. So full team. veteran MCAT instructors with us here tonight, and I'm super excited to be here for a variety of reasons. As I said, my name is Petros. I am an instructor here at Kaplan. I've been so for now a little over 19 years. In that time, have helped tens of thousands of students like yourself through this process as far as the MCAT. So super excited to be here tonight with you, talk about acids and bases. We're going to get into all the fun stuff that comes with acids and bases, except for there's one thing that's not fun about acids and bases, and that is if you spill them on yourself. So we're not going to have that danger here tonight. I'm also the director of our pre-health programs here at Kaplan. So I kind of wear a couple of hats. Started as a teacher, and now I'm the director of our pre-health program. So get the opportunity to work with students like yourself, both in the classroom as well as kind of in the development of our programs and in the ongoing kind of advancement of what it is that we're doing. And helping all of you get to that point of wearing a white coat as far as your careers and your career aspirations are concerned. So what we're going to do here tonight, as Ali mentioned, this is a session that is straight from the MCAT channel. The MCAT channel is part of our MCAT program. It's actually the live instruction portion of our course that you can customize. There's a kind of fixed portion that everybody goes to, and then because we're all different, we have different strengths and weaknesses, we have the MCAT channel where students can actually pick and choose the sessions that they need to go to. You can go to all of them, you can go to some of them, you can go to none of them, but really we encourage students to go to as many as they can. And the thing about the MCAT channel is that it gives that opportunity to work with a small team of instructors, but even more so, it gives the opportunity to really customize your preparation, because if you're a rock star in acids and bases, maybe you don't need to come to those sessions, but if you're not so great at thermodynamics or something like that, you go to those sessions. So really it's an opportunity to customize things. One thing that I will add, because we didn't spend a whole lot of time on the slide that showed the different sections of the exam and the kind of distribution of this test, is that the MCAT's a different beast from the way that we have learned the sciences in our undergraduate courses, right? When you take organic chemistry, the organic chemistry professor is an organic chemist who wants you to learn organic chemistry the way she knows organic chemistry. Same thing with physics, same thing with bio. You get to the MCAT, and it's a very, very integrated exam because you'll have a section like the Chem Phys section. It's the chemical and physical section, chemical and physical sciences applied in a biological context. So something like the circulatory system, which is a very, very biological system, in fact, can be tested using physics because it really is nothing more than a fluid system where you've got blood moving around a series of pipes. Those pipes happen to be called arteries and veins. And so when you think about the MCAT, you think about your preparation for the MCAT, you need to be thinking about the integration of those sciences, which of course is very, very important because when you are a physician, all the systems are connected to each other, right? If a patient is having kidney failure, that's going to cause other problems. Or you have liver failure, that's going to cause other problems down the line, right? If you're not able to produce enough albumin, you're going to end up with edemas. And so everything really is connected. And the MCAT starts to do that. And even more so, the MCAT's not just testing you on the straight recall of the sciences, it's testing you on your ability to apply your knowledge of the sciences. And so what we're going to look at here today with acids and bases really is more of this lesson is acids and bases a primer because it is the fundamentals of acids and bases. But acids and bases, they show up everywhere, right? I mean, if for those of you that have, anyone who's taken biochemistry, I think you can back me up when I say this, that acids and bases show up in biochemistry, right? They show up all over the place. In fact, something even like, not a topic we're going to look at here tonight, but redox reactions. We learn about redox reactions initially in a general chemistry class usually. Then you get to biochemistry or even general bio, and you're learning about the electron transport chain. You realize, wait a minute, it's really nothing more than a series of oxidations and reductions, right? You've got electrons that are being either, they're being passed along. They're being, something is either gaining electron or losing electron. And so the sciences are very much connected, and the MCAT does reward you for your ability to make those connections. So part of your preparation, especially those of you who are taking the test, I saw a good number of you are taking the test this week, so good luck for sure, because it's getting close to test day. But as you're studying for this exam, it's really important to be thinking about these things in the broader context. In fact, the worst thing that you can do for yourself, and this is just a bit of advice, which I know my fellow instructors will back me up on, the worst thing that you can do for yourself is essentially just study from your college textbooks, because you are not going to actually be tested in the same way. You haven't seen questions like these. So what we're going to do here tonight is we're going to go through the basics. That's no pun intended, although I guess it could be a pun. Go through the basics of acids and bases, and also look and see how it could be applied and how it can be how it can show up on the MCAT. And really the goal of here tonight is, of course, for you to have a little bit of fun, but also to learn something. So we're going to try to do both of those things. Studies have shown that if you enjoy yourself while you're learning something, you're more likely to remember it down the line. So ask the questions that you have. That's why we've got the team here, and we're gonna go through this stuff and let us know what it is that you need and what it is that is on your mind as we're working through these things. So first and foremost, this is what we're going to talk about. We're going to talk about acids and bases and their strengths and really what the acid-base strength means. And then we're going to talk about gram equivalent weight and normality, two kind of smaller topics that are often forgotten, but actually can cost you a lot of points. I've had a lot of students through the years who've missed a lot of questions earlier on in their preparation because they forgot about normality. And so we're going to take a look at normality, and it's something that unfortunately isn't taught all that well at the undergraduate level. For some reason or other, that's something that is just kind of assumed to be known, and then you get hit by it and you're like, wait a minute, I didn't learn something that I needed to learn, and it shows up on the MCAT and becomes all too important. As we go through this, please do take notes. I mean, this is going to be relevant for you later on. One thing I will kind of warn you about ahead of time, I'm going to walk you through process in some cases, especially when we look at questions. So, the goal of tonight, I mean, you're never going to see the questions that we show you here tonight on the actual exam. So the goal, the real kind of benefit of your time is to really look at the process that we're going to show you of what to do to get through these types of questions, because you're not going to see this question, but you're going to see another question that's very similar to it in the future. So, if you learn the process, you'll be able to replicate it 100 times. If you just fixate on the one specific question that we have in front of us, that's not going to help you as much. So that's a little bit of a kind of top tip, word of advice to you, friend to friend, somebody who wants you to do well on this exam. So first and foremost, what makes an acid or a base strong? It's not muscle strength, obviously, right? Acids and bases don't have muscle matter, so it's not like, oh, he's a strong acid or she's a strong base, and that's because there's a lot of muscle mass there. Really, what makes something or defines an acid or a base as being strong is how well they're able to completely dissociate in an aqueous solution. So you throw the acid into water, how well it's able to fall apart, right? How well it's able to separate its different components. And we'll use HCl as an example. HCl, you tell me, strong acid or weak acid? Generally speaking, I mean, if I were to pour hydrochloric acid on you, not that I want to pour hydrochloric acid on you, what do you think? Where does hydrochloric acid fall in the grand scale of things as far as our strengths are concerned? I see a couple of you are typing in that it's strong, and you're absolutely right. I mean, the reason why hydrochloric acid is strong is because it has a complete dissociation. You throw, hydrochloric acid as a salt, you can have it as a salt, you throw it into water, and it's going to just completely dissolve. It's a very, very strong, very, very complete dissociation, making it a very, very strong acid along the way. So that's how we define whether or not something is strong versus weak. Acetic acid, on the flip side, stuff that you find in vinegar, a little bit weaker of an acid, right? You throw acetic acid into water, you're not going to get complete dissociation. You're going to have some acetic acid that's going to be left undissociated, right? So it's going to stay in its original form. So to measure the dissociation of an acid, chemists have defined a term, and this is called Ka. All right, so not Ka, it's Ka, which is the equilibrium constant of the acid. So that is what the Ka is. It is a means of measuring the dissociation of the acid. So stronger acids that are going to completely dissociate are going to end up with a high Ka. What do you think a weaker acid is going to show up with? And this is, again, it's a softball question. We're getting warmed up. I don't want to throw too much at you right at the beginning, but if you've got a weaker acid, what do you think its Ka is going to be? And I see a bunch of you are typing away, and it's going to be relatively low as far as the number, right? So strong acids are going to have a high Ka, weaker acids are going to have a low Ka. When you look at Kb, the Kb is the dissociation constant of a base. So Kb follows the same rules. Stronger bases will completely dissociate, so they'll end up with a high Kb value. Now, to be perfectly clear, and to not confuse anyone, but I'm going to confuse you potentially, usually, because chemists, and forgive me if anyone is a chemist or is related to a chemist or knows a chemist, but chemists, generally speaking, are kind of lazy, and that's a good thing. They like to keep things in nice, easy order. So rather than oftentimes speaking about Ka and Kb, chemists will just speak in terms of Ka. So a strong base with a high Kb value is actually going to have a low Ka value. So you kind of, in order to keep the terms kind of equivalent, they'll use that sometimes as to make the comparisons a little bit easier. So if you're comparing hydrochloric acid versus NH3, good old ammonia, you might refer to them only by the Ka values. But don't be confused by that. It is one and the same thing. There's actually a relationship between the Ka and the Kb, which I'll show you here in a little bit. So hang tight for about 5 or 6 minutes before we get to that little association between the two. So strong bases going to have a complete dissociation. They're going to end up with a high Kb. Your responsibility for the test is, and I generally don't like recommending students to memorize lists, but this is one that I would recommend that you memorize. Kind of know the common strong acids, kind of a good important list to know. These are the big ones that will show up over and over again on the MCAT. So HCl, HBr, HI, H2SO4, HNO3, HClO3, HClO4. What do they all have in common, though? What is the one thing that each and every single one of these acids that's on the list that they all have? And there is a reason for them all being on this list and having this commonality between them. So, what do you think? What do you think is common between all of these? Good old protons, right? They're all going to give off a proton, and it's a readily available proton. There you go, right? There is a nice proton that's just going to be ready to give off. So it's not the whole hydrogen that's going to go. It's just going to be the proton. When HCl dissociates, it's an H plus and a Cl minus. HBr, it's an H plus and a Br minus. H2SO4, it's an H plus, and then it's HSO4 minus that stays by, and then you dissociate the second proton, and it's SO4 2 minus that sticks around. So, these all have that proton that can be easily given up. Common strong bases, sodium hydroxide, KOH, any of the hydroxides, basically. So the theme you'll see here is that they've all got OHs involved. So generally speaking, when we're looking at the strong acids and strong bases, you've got either protons or hydroxides that are present. Now be careful, there are bases that exist, in fact a very common base that we are aware of, good old ammonia, that don't have OHs. So the earlier definition, it was called the Arrhenius definition, and that was AR is how it was spelled, gave the definition of an acid as being something that donates protons, the base being something that donates hydroxides. That is actually considered an erroneous definition now, even though it was called the Arrhenius definition. I guess there was a little bit of a foreshadowing that was happening there. The reason being just because it can actually be generalized even more so. And of course, you have the Bronsted-Lowry definition, which we won't go into here tonight, which defines everything in terms of acceptance or donation of protons. And then the most correct definition is the Lewis definition. So the Lewis acids and bases look at electron pairs because everybody's got electron pairs. So it's a nice, easy way to be looking at things. But regardless, when you look at strong acids, strong bases, these are the lists that you should know. Generally speaking, if something is not on this list, then it wouldn't be considered as a strong acid or a strong base. Okay, so that's the kind of the general way to be thinking about this along the test. All right, so those are some terms. So we got that covered. Let's dive a little deeper into this. Let's actually look at Ka. So when we're looking at the dissociation constant, really what we are measuring is how much of that proton is going to be, it's going to fall off. What fraction is going to be lent away. So here's acetic acid. Now acetic acid, I'm going to go back a slide here. not on the list as far as strong acids. So acetic acid, we can define this as being a weak acid. We look at acetic acid, and you throw CH3COOH into water, and this is what happens. You've got protons that are going to come off of the acetic acid, and they're going to protonate the H2O. Now, it's not all of the protons, meaning it's just a fraction of the protons. So of all the acetic acids that you throw in to the water, a fraction of them are going to dissociate because it is not a complete dissociation. So the way you look at this as far as the values are concerned, the Ka value of acetic acid is 10 to the minus 5. So pretty weak as far as the number itself is concerned. Similarly, you get HCl, which is on our list. The Ka value here is going to be 10 to the 8th power. So I mean, there's a magnitude of 13 powers of 10 between acetic acid and our good friend hydrochloric acid. So hydrochloric acid, it's a pretty strong acid when you're looking at it from the overall perspective of things. Now you take this one step further, and you say, okay, well, what about the conjugate base? What about the part that's left behind? So if the acetic acid is the one that's giving off the protons, this group here is what's going to be accepting the protons. So that's the conjugate base. Now here's the nice thing. The Kb is 10 to the negative 9. And that's not completely coincidental. So just hang on to that number here for a second. At the same time, that would be considered a weak acid, right? So we've got a weak acid bit there. And then over here, we look at HCl. Its Kb value is 10 to the negative 22. Now, we're going to do something fun here. If I were to add negative 5 and negative 9, what value do I get? What's the value that I get when I add negative 9 and negative 5 to each other? What is the bit that I am going to be getting as far as this is concerned? Just do a little math. Negative 5 and negative 9. And then at the same time, go ahead and add 8 and negative 22. So if you do those two, you get negative 14. Interesting. It's interesting that you get negative 14. Somewhat coincidental, maybe not. We'll see that here in a second. So chlorine, of course, is an inert base. We look at base strength. We look at Kb. Similar type of story. We do this in the flip. What's the Kb value going to be here? What's the Kb value on this one? This is not meant to trick you. It was on the previous slide, but we're going to figure this out here. So we're going to leave this as a question mark because we're going to actually try to solve this guy out. We look at NH2 minus. It's going to have a Kb value of 10 to the 52. That's huge. This is a nice, good, strong base is what it comes down to. So very, very strong base as far as its ability to pick up protons and become NH3 and leave behind the OH minus. So we're creating these OH minus species, which makes us a pretty cool base along the way. So we've got an inert acid over here as we're moving through this. Now, where that negative 14 value comes into play actually comes from our good friend water. So here's the kind of the exciting moment of all of this. If you have H2O and H2O, you got two waters, there will be a fraction. In fact, the fraction is 10 to the minus 14 that will dissociate into H3O plus and OH minus. And this is what we refer to as being the autoionization of water, or the constant associated with water. Okay, it's 10 to the minus 14 value. This value, to be perfectly transparent and perfectly clear, is the value at room temperature. So this value will change. If I were to heat up this water, would I expect more or less dissociation? Would I expect a higher fraction or a lower fraction to be dissociating along the way? What do you think? Temperature does matter. Okay, temperature matters a lot. And if I were to take this into account and say, all right, I'm increasing the temperature, you guys are on it, I would expect there to be a higher dissociation. So in fact, at around 60 degrees Celsius, you don't need to know this number for the test, but I'm telling you this number, at around 60 degrees Celsius, the Kw of water is 10 to the minus 13. Now here's the weird part. You usually take a shower at around 50, 60 degrees Celsius. That's about right. If you want a nice, warm bath almost, you would, 60 is a kind of a good number to be at. Yet you don't get an acid burn when you take a shower, right? Or if you take a bath, you don't get an acid burn. And the reason for that isn't because the water is no longer neutral. The water is still neutral because even though there's more dissociation, there's a higher fraction of the water that is dissociating, you end up still with a 1-to-1 ratio of your H3O plus and your OH minuses. So it's still neutral at the end of the day. So don't freak out and think, okay, I got to take a shower now for the rest of my life at 25 or so degrees Celsius. Not the case, right? You can definitely still take the warm bath or the warm shower. You're not going to get an acid burn because you still have an equal number, right? You have equal amount of base versus the amount of acid. So there's still a ratio of 1-to-1 between those two. But there's a higher fraction of them that are dissociating at the end of the day. Okay, so really important to kind of keep that in mind. Now, going back to our original formulas here, original reactions that we had, the Ka was 10 to the minus 5 over here. Remember, we wanted to solve for the Kb. Well, here's the this is the party trick that you can impress your friends with if you've forgotten this. If you were to combine these two reactions together, since you have CH3CO minus on both sides and you have CH3COH on both sides, they actually cancel each other out. And the sum of these two reactions is 2H2O for H3O plus and OH minus. So the Ka is -5, the Kw is -14. Well, the Ka times the Kb will give you the Kw. So assuming this is at 25 degrees Celsius, the Kb value here is going to be what number? This is if you need some refresher on exponents, as long as you have the same base value, you can sum up the exponents to end up to solve out, for your equation. So 10 to the -5 times 10 to whatever x value is equal to 10 to the -14. The exponents would be -5 plus the x equals -14. So really at the end of the day, the Kb value here is going to be 10 to the -9. All right, so this is where that 14 value really comes to play. We like the number 14. And now I'm going to tell you some a personal bit of information. Today is May 14th. My birthday was a month ago. I was born on April 14th. So if you ever forget the important number, just remember my birthday. I don't know if maybe that's easier for me than for all of you, but that's why I always tell my students. It's just remember that my birthday is on the 14th, and remember the 14 number is a very, very important number as far as your acids and bases are concerned. So hopefully you remember that. If anybody was born on the 14th, then there you go. You can remember it nice and easy. Okay, so Ka times the Kb equals the Kw, which is equal to 10 to the -14. Very important number for us along the way. So let's do this. We're going to go through a little exercise here. It's a little bit of a drill. We're going to walk through this little chart here. Hydrochloric acid, very, very large Ka. And the Kb of the base, the Cl minus, really, really small. So small it's negligible. Same thing with H2SO4. Very large Ka value. HSO4, very negligible Kb value. HNO3, very large Ka value. NO3 minus, very negligible value. But let's get to HSO4 minus. This has a Ka, I'm just going to tell you, of 10 to the -2. What do you think the Kb value is of SO4 2 minus? What do you think that number is going to be? So go ahead and type in your predictions along the way. Brandon, I'm glad you'll never forget. Linus, I'm glad you'll never forget. I expect a birthday card over here. I'm just kidding. What is that number going to be? According to this, according to our little values, it's going to be 10 to the -12, right? 10 to the -2 times 10 to the -12 will give you 10 to the -14. That 14, -14, shows up again. H3PO4, H2PO4 minus. If this value is 10 to the -3, we can predict that this value is going to be 10 to the -11. Okay, so again, I'm not speeding through this, but this is -3 and -11 adds up to -14. That's not coincidental. HF, 10 to the -4. F minus is going to be 10 to the -10, right? So this is a pattern that we start to see because it's all related back to the Kw. Kw is Very, very important. So we saw this one already. Acetic acid, 10 to the -5 and 10 to the -9, right? So we've seen these bits before. So these, again, add up to 10 to the -14. Same thing works in the opposite direction, though. NH4 plus, it's got a value of 10 to the -9. We look at this, we say, okay, NH3, it's 10 to the -5. Cyanide, scary stuff. It's got a value of 10 to the -11 as far as the Ka goes. So the cyano group, I should say, is going to be 10 to the -3. Don't play with cyanide. Be very, very careful. And also, be very careful of the pits of stone fruits. So things like apricots and almonds too, actually. So be very, very careful of those because they have levels. They have a little bit of cyanide in them, and they can get a little toxic sometimes. So that's a natural defense mechanism those guys have. There's your little like side tip that can impress your friends at a dinner party or next time you're out getting coffee or something. All right, we won't worry about these guys because again, NH3 we would expect it to have a very negligible Ka value. OH minus, that's kind of your classic base. Very negligible Ka value. Same with H2. Very large Kb values over on this side of the chart. Okay, so the patterns kind of continue and the patterns do play out. So with that said, we're going to put a poll up. So Shwarya, if you don't mind, let's put a poll up for this one. But we're going to do this one together. Because as I said, I want to walk you through process. So we're going to do this first one together. We're going to walk through the process. So don't try to jump at an answer per se, but work through the process because this process will help you out on the test. First rule of the MCAT when you're looking at questions, don't read the answer choices ahead of time. Very, very bad idea. It actually ruins your timing because you got to go read the answer choices, then you go back to the question, and you read the answer choices again. So end up wasting it. There's a lot of urban legends out there that that say, if you read something, some stuff on SDN or on Reddit, it's like, oh, read the answer choices first. No, it's actually the worst thing you can do for yourself. Trust me when I say that. It is not worth your time at all. And I know that my colleagues here will back me up on that. So the way you do it, though, you read the question, take a glance at the answer choices. So look at the answer choices and say, okay, I see words. Now here's the deal. This is we're going to take a step back here for a second. If you see words in the answer choices, that means you are being tested on a specific concept or a specific relationship. All right? So that's the key. You are not being tested on actually calculating out a number. If you see numbers in the answer choices, then chances are you're being asked to calculate on a number or decipher a number. But if you see words, then you're really being tested on a relationship. And if you just look at these answer choices for fun, it says near zero, less than, much less than zero, about one, or much more than one. Question's asking you the ionization constant of H2S. And we think about H2S, you throw H2S into H2O, the dissociation is going to lead us to H3O plus and SH minus. That's where we're going to see as far as the equilibrium is concerned. So if we want to figure out the ionization constant, what we would do is we'd say, okay, well, the H2S, relatively weak acid. How do we know that that's a weak acid? How do we quickly know that that is a weak acid? This is not a trick question. It's not a trap question. What is it? How do we know that H2S is a weak acid? What's the very simple answer if you were paying attention just a few moments ago? What is it? Go ahead and type it into the chat. Curious to see. Who was acutely paying attention or keenly paying attention? It's not on the list. It's as simple as that. That's my explanation. It's not on the list. So if it's not on the list, it's got to be weak, right? So if it's on the list, it's strong. If it's not on the list, it's weak. That's the bottom line. So H2S, weak acid, which means you're going to end up with a weak base as far as when it dissociates. So at the same time, we say, okay, well, if we know that, and we know that value, so 10 to the 0 value, what's 10 to the 0 equal to? It's 1, right? So 10 to the 0 is 1. Since I know that this is going to be a weak acid, therefore my ionization constant is going to be a value that's going to be less than 1. It's going to be really less than 1. So it's going to be answer choice B. Now, here's where it gets a little bit confusing. Why not A? Because near 0 and much less than 1 kind of sound like the same thing, right? They kind of sort of sound like the same thing. Here's the problem. If the Ka of the H2S was near 0, then that would mean that the Kb of the HS minus is really, really large. And it's not going to be really, really large because it's a weak base. So we know it's going to be much less than 1, but it's not going to be near 0. Near 0 means like 10 to the negative 99 or 10 to the negative 60 would be something that would be near 0. It's not going to be that close to 0. So be very, very careful about this. That's the tricky part about the MCAT, is that sometimes they'll put this language in there that you have to be a little bit interpretive of, and there's a subtlety to it. You would never want to describe this as being near 0, but you would say that it was much less than 1, right? So it's not going to be a value that's going to be close to 1. It's going to be much less than 1. So even 10 to the 0 is of course 1. 10 to the minus 1 is 1/10. So that's already much less than 1. 1/10 is much less than 1 because it's order of 90% less than 1 as far as the values are concerned. Okay, so again, process-wise, look at it, think about it, look through your answer choices, and try to find the one that matches your relative prediction. We'll work a little bit more with that as we go through here. But now what we want to do is we want to do something that is extremely relevant to your future success on this exam, and not just on the chemistry questions. This will show up in biochemistry. This will show up, logs will show up in physics type problems as well. So let's just go through this. We're going to talk about the P's of things. So anytime you take the P of something, okay, no giggles, because it's we're all adults here, right? So if you're peeing something, I made myself laugh when I say that. So when you're peeing something, that means you are taking the negative log of it. So if it's the pH, the POH, the pKa, the pKb, the P whatever, when you pee something, you're taking the negative log of it. So when we look at the pH, that's the negative log of whatever the concentration of the protons is. The POH is the negative log of the concentration of the hydroxides. Now, remember the number 14 and how important the number 14 was. The pH plus the POH will equal 14 at 25 degrees Celsius. That's why there's a little asterisk that's there. The pKa is the negative log of the Ka. The pKb is the negative log of the Kb. The pKa plus the pKb will equal 14 at 25 degrees Celsius. So for fun, if we kind of walked through this little chart here, if I had the concentration of my protons or my OHs or my Ka or my Kb, whatever it was, what would the P of 1 times 10 to the negative 1 times 10 to the negative 1, what would that be? What would the P value of that one be? So the pH of 1 times 10 to the negative 1, what's the value that we're getting for this one? The value we get. This one's a good warm-up question. Nice and easy. I see a couple of you are typing in the number 1, and you would be absolutely right to type in the number 1, right? This is a 1. So the pH is going to be 1. The negative log of 1 times 10 to the negative 1 is just 1. Similarly, 1 times 10 to the 8, the p-value of this would just be negative 8. All we care about is this exponent. Put a negative in front of it, negative 8. Nice and easy. Here's the problem. On the MCAT, you're not going to get nice and simple, cleanly written 1 times 10 to the negative 1 and 1 times 10 to the 8. It's going to be a little more complicated than that. You're going to get things like this. You're going to get 6.4 times 10 to the negative 3. So your initial kind of knee-jerk reaction, at least my knee-jerk reaction, is to go for a calculator. But guess what you don't get on the MCAT? Anyone want to take a wild, crazy guess of what you don't get on the MCAT? And it sucks that you don't get one of these. Actually, it's actually good for you that you don't get it, but you might feel like, oh no, I'm so used to my calculator. You don't get a calculator, right? You don't get a calculator on the MCAT. But here's the good news. You don't actually, right? You don't actually need a calculator on the MCAT, and you don't need a calculator to solve this problem. Here's the good news. 6.4 times 10 to the negative 3 is actually really easy to solve the P of. I'm going to show you how. So here's our little trick. Remember, the P of anything is the negative log of anything. So if your anything follows the structure of m, so here's our 6.4, times 10, there's our 10, to the negative n, so here's our negative 3, the n is going to be 3, right? The m is 6.4. Here's the trick that you can use, and this always works. This always works. You're going to take the n value, so the n value up here is the number 3, and you're going to subtract 1. So you're going to put a 2 before your decimal point. Okay? So you have 3 minus 1, not negative 3, the 3 minus 1, because it's just the n value, not the negative n value. You put a decimal point. And then you're going to have 10 minus whatever your m value is. Now here, it's 10 minus 6.4. We can call it 6 if we wanted to, make our life simple. So 10 minus 6 is just 4. So we would approximate that our P of 6.4 times 10 to the negative 3 is around 2.4. And if you did that, you'd get the question right, because there's only going to be one answer choice that's going to be close to that number. So the MCAT's not going to give you answer choices that are like 2.4, 2.41, 2.42, 2.43. That's not what they're there for, right? That's not what they're there for. They're there to test your ability to conceptually understand things. And so you can use this to your advantage. And they're going to never give you answer choices that are so close to each other that you would have to precisely calculate it out with a calculator. Let's try this one on our own. I'll give you guys 20 seconds. Figure it out. You got the formula here. You got 2.1 times 10 to the negative 8. We don't need to put a formal timer up, but start work this one out and put your answers into the chat. I want to put, best way to learn something is to actually practice using it. So go ahead and use it. And I saw a couple of you put in the chat that there was no calculator, that you're done. Don't be done. Don't be done. It's not. You don't need it. You don't actually need a calculator. In fact, it's funny. You might, if you were to get a calculator, actually would slow you down a little bit because you'd be like plugging in to get the right answer. So anyway, put your answers in. So work this out. 2.1 times 10 to the negative 8. Remember, the m is the 2.1. The negative n is negative 8, so the n is 8. So you've got all the tools that you need here. Got everything, and I see a lot of you are saying 7.8, and you would be right? So it's going to be 8 minus 1, so that's 7, and then 10 minus 2, so it's going to be 8. 7.8 it is. Now here's the cool part. It works in reverse too. If I gave you the pH, you can predict what this concentration was. So if this 13 is the result of something minus 1, what should be going into this first part right here? Should be 14, right? So the exponent is going to be negative 14, and this 0.3 is the result of 10 minus something to get us 3, so it's going to be 10 minus 7 in this case. So my coefficient there would end up being 7. So this would be 7 times 10 to the negative 14. If you were to go the other way and you were to solve it out, you'd end up with 13.3. So this works in both directions, right? It is working in both directions to make this happen. 1.8. Why don't you try it on your own? So if you started with 1.8, the pH or the POH or the pKa is 1.8 or whatever, and you want to figure out what it originally was before you peed on it, what would it ultimately be? So go ahead and work that out and put that into the chat. I'm so proud of you. You guys have embraced this very, very quickly, which is very nice. Very, very nice indeed. Don't always do a gut check, right? If you end up with like 60 as your answer for a pH, that's not right? You know that's not right. You don't have pHs of 60 usually. So be careful about that. You can always use a gut check to make sure that you're okay. So I'm seeing 2 times 10 to the negative 2 as a pretty popular answer, and you'd be right? Because this 1 is a result of something minus 1, so that's going to be 2 there. And then, of course, this 8 value over here is going to be 10 minus the 8 would have given us the 2, right? right? So that's how or the 10 minus the 2, excuse me, would have given us the 8. So work it in reverse, and we end up with the 2. So it's 2 times 10 to negative 2. Very nicely done. I think, team, what do you think? Do you think they've earned this? I think they have. I'm gonna give you a little star because you've earned it. So nicely done. I'll give you a virtual high five as well on that one. Good work. All right. So now that you've gotten your star, now that you've gotten your high five, we're gonna give you a minute, and I want you to solve this question, and we're gonna put a poll up onto the screen. So you got a minute. Take it away. Try it out. Put your answers in the poll, and let's see how we do. Don't be trapped, but you have learned everything you need to solve this question. All right. Well, let's see how we did on this one. It looks like about half of you have chosen, a little more than half of you have chosen A, a little less than half of you have chosen C. So we've got pKa values here, right? We got 9.26, 10.64, 10.98, 10.76. If we were to go and figure out the pKb's, remember these have got to add up to 14. So the lowest pKb is 3.02, which is this guy right here. And if we're looking for the strongest base, the stronger the base, the lower the pKb, because it's going to be the higher what? The lower the pKb means the higher Kb value. So the correct answer on this one is answer choice C. Now here's a little top tip for that, right? A little top tip for that is you do not actually need to go and calculate out the pKb's. What you could have done is said, okay, the one with the highest pKa will be the one with the lowest pKb, and the lowest pKb is going to be the strongest base. Therefore, that's the one that I'm going to choose. So you don't actually have to do any math to solve this problem. This problem could be solved just using the one knowledge fact of knowing that the lower the pKb value is, the more basic it is going to be. The stronger the base it's going to ultimately be. All right? So it looks like we were about 40% or so on C, which is fine. Those of you that chose NH3, you chose NH3 because it had the highest pKb value, and therefore it is the opposite answer choice. It is what we refer to sometimes as being the 180-degree opposite answer choice. It is perfectly opposite of what you wanted to choose. All right, so you just have to flip around the logic, and you end up with answer choice C. If you have questions about that, please do let us know. Let us know in the chat. We'll be able to answer those away for you along the way. But let's try another question. Let's try one more. So here we go. So we got question number 3. I'll give you another minute and take it away. All right, so put your answers into the poll. I will unblur myself. That was fun. Don't know why that's still happening there. Let's take a look though and see what we got in the polls. Ashwarya is going to give me the results here in a second, and we'll see what we've got. Looks like 36% of you have chosen answer choice A, which is good solid showing, and about 20% for the rest of them. So let's see. So we're kind of a little more mixed on this one. So this is a fun one. We got 50 grams of an unknown acid with a molecular mass of 200 grams. So here's my question to you. If I've got 50 grams of a molecular mass of 200, how many moles of acid do I have? Also, that'd be a really cool name for like a science rock band, moles of acid. So how many moles of acid do we really have if we've got 50 grams and a 200? It is 1/4, right? It's going to be a 0.25 moles of acid. We are told that the Ka is 8 times 10 to the negative 8, and it's dissolved in 500 milliliters of water. So there's nothing straightforward about this. It's 0.25 moles in half a liter, which means the molarity is actually half a molarity, right? It's half molar. It's 0.5 molar as far as the acid is concerned. So that's the value that we have. And then we say, okay, well, we got the Ka value of 8 times 10 to the negative 8. So here's what we got to do. We got to set up an ICE chart. So this is a nice chart. If you haven't used these before, or it's been a while since you've used these, you do want to use these. Initially, we would have had a concentration of 0.5 molar of the acid. Initially, we would have had nothing as far as the concentration of protons and nothing as far as the concentration of the base, right? The concentration of the conjugate base. Then what happens is we're going to change a small fraction of those, not the whole thing. It's not complete dissociation. We're going to change X amount. So we're going to subtract X amount from the HA, and we're going to add X amount to the protons and add X amount to the A minuses. So at equilibrium, what we have is 0.5 minus X and X as far as our concentration of protons and our concentration of A minus. Then we can set up the Ka formula. The Ka formula is your concentration of your dissociated products divided by what you originally had. So really this is going to be X times X over 0.5 minus X, and that is going to equal the Ka value of 8 times 10 to the negative 8, right? This is the value that was given to us. Now, remember earlier, I said the chemists were lazy. And they are lazy because they don't actually care about this little tiny bit that is dissociated. And it's such a small amount. So yeah, so a couple of you are asking like, why is it minus X? It's minus X because the HAs that dissociate, right? There's some fraction of those HAs that dissociate, and we call that fraction, that amount is X. And so if I take an HA and I dissociate it, it becomes an H and an A. It becomes an H plus and an A minus. So there's X more of those than we started off with, right? We had 0 to begin with, and now we end up with X's of those. But in this formula here, we don't actually care about this minus X. This is a relatively small amount. We do care about the X's in the numerator because that's the entirety of the numerator, right? That's all that's there. And part of the reason why we also don't care about this is because then you'd have to set up a quadratic formula, which you just don't have time for on the exam. So you don't worry about that. But even in a chemistry class, they teach you to ignore those little X's there. So really what you have is you have X squared divided by 0.5 is equal to 8 times 10 to the minus 8. And now it's a matter of just doing some algebra, right? This is why algebra is important. You oftentimes think when you're taking algebra, why do I care about algebra? Well, we care about it because we multiply through by 0.5, which would leave us with X squared equaling 4 times 10 to the negative 8, right? Half of 8 is going to be 4. So X squared is equal to 4 times 10 to the negative 8. We take the square root of this. The square root of 4 is 2. The square root of 10 to the negative 8 is going to be negative 10 to the negative 4. So our X value is equal to our proton concentration, which is equal to 2 times 10 to the negative 4. So this is our X value. And Now we got to take this value here and we got to figure out the pH. What system that we saw earlier today can we use? And we call it the ninja trick. So what system can we use in order to, Katie, I feel bad for your students, but go back and tell them to do this the short way. It's funny. It's funny. We do forget about it. Those poor little negligible bits. We can use the ninja trick here. And so really remember, it's the pH is equal to this n value minus 1. So 4 minus 1 is equal to 3. And then 10 minus this 2 value. So the pH is going to be approximately 3.8. Notice there's only one answer choice. Only one answer choice that is equal to 3.8. And that is the correct answer choice B, right? So 3.7 is the one that it's going to be. For those of you that chose A, my guess is, so it's just a hunch, my guess is you got to this point here and you said, 2, there's my 2, and you pick that one as your answer. But remember, there is one more step that you have to take in order to get to this place. Cool. All right, nicely done. Nicely done. You guys having fun? Learning something, right? Getting re-engaging those parts of your brain that deals with this stuff. Getting it ready for the test. We'll do this last one here together. Students interested in determining the Ka of an unknown monoprotic acid. He makes a 0.05 molar solution and measures the pH to be 4. Now we got to figure out the Ka. So we've got the pH, we've got the molar concentration. If the pH is equal to 4, the way we would do this is say, okay, the pH is equal to 4, so the proton concentration has got to be 10 to the minus 4 molar. That's that much we know. And since the Ka is equal to the concentration of protons times the concentration of the A minus divided by the HA value, we could say that this 10 to the minus 4, which is this guy here, times 10 to the minus 4, which is this guy over here, it's going to be the A minus, the corresponding A minus, divided by my original 0.05, which is here. Really, this is just a matter of doing some plugging and chugging. Notice there are numbers in the answer choices, and you take it from there and you say numbers in the answer choices, and you take it and say, okay, it's going to be 10 to the minus 8 times 1 or times 0.0 divided by 0.05, which is the same as saying 1/20th. So it's 1/20th times 10 to the minus 8. So that's going to be 2 times 10 to the negative 7. So it's a little bit of manipulation that has to happen. Here's a fun way that you could do this. You know that answer choices A and B are too big, quite frankly, because you know you're going to end up with something 10 to the minus 8, and then some change is going to happen here. This value is too small, so you know that the answer has to be answer choice C. There was a good point, Lennis, you brought up a good point as far as that last problem, that it might be too long for the MCAT. It's actually not. That's actually the most efficient way to do it. There are going to be questions on the MCAT that will take you longer. There are going to be questions on the MCAT that take you a considerably shorter amount of time. So we'll average out, of course. Here's the deal, though. If there are problems that you know you can get right, but you know it's going to take you a long time, and you might have the opportunity to get more questions right somewhere else, go do those other questions. Go do those other questions. Because, you know, especially if you get a question that is one that you're like, I know I can do this, but it's going to take me a long time. Go do other questions and then come back to that question later on, right? So you're not eating up energy and time with that question on the exam, because you might be giving up more questions that you could have done down the line as far as the test. Just remember, make sure you mark an answer, because there's no penalty for guessing on the test. You don't leave any questions blank at all. All right, cool. So let's shift gears, and if there are questions, let us know what they are. We'd be more than happy to get those answered for you along the way. Remember earlier I said we're going to talk about gram equivalency and normality, and these were oftentimes, you know, these sadly forgotten concepts in general chemistry. So we're going to remember them here. When we are looking at a reaction, specifically with acids and bases, what we really care about are the components that are going to be doing the reacting. And here's what I mean by this. Hydrochloric acid is going to completely dissociate, and it's going to produce equal parts protons and chlorines. 1 mole of HCl is 1 equivalent of an acid. However, if I were to take something like H2SO4, H2SO4 is special. In fact, it's very special. It can give off 2 protons. So HCl is what we consider to be monoprotic. H2SO4 is diprotic. You also can have a triprotic. So H3PO4 is a triprotic. So H2SO4 gives off 2 protons. So 1 mole of H2SO4 is not 1 equivalent of an acid. It's in fact 2 equivalents of an acid, because you can give off 2 protons for every one H2SO4 can give off 2 protons. So it's double the acidic power at the end of the day. So the reacting equivalents become important, because if you were to be kind of comparing things, or you'd be trying to neutralize H2SO4, if you had 1 mole of H2SO4 and 1 mole of sodium hydroxide, you wouldn't actually get a neutralization, because the equivalencies would be off. So you have to be very, very careful about this. So calcium hydroxide also has 2 equivalencies. So 1 mole of calcium hydroxide gives you 2 equivalent bases. So if I wanted to neutralize H2SO4 and I had 1 mole of H2SO4, I would want to use 1 mole of calcium hydroxide. If I were to have 1 mole of calcium hydroxide and I put in 1 mole of HCl, I wouldn't neutralize the calcium hydroxide. In fact, I would still have a very basic combination there, because I would have 1 whole equivalency of base still left over. So you got to be really, really careful about this. This is how they try to trick you. Here's what it comes at, right? Here's what it comes down to. They will try to trick you on the MCAT, because they're not going to say, oh, this one is 2 equivalents and this one is 1 equivalent. They're going to just give you the chemicals, and you go, okay, I got to remember whether it's what its equivalency is going to be. So there are 2 ways to look at equivalency. The first is what's referred to as the gram equivalent weight. So the gram equivalent is the grams per equivalent. So you've got your grams per mole, and then you have your moles per equivalent. So NaOH is 40 grams per mole. So if we were to look at this and say NaOH is 1 mole for 1 equivalent, then it's a 40 grams per equivalent. On the same side, though, or in the same kind of vein, Na2CO3 is 106 grams per mole. But how many equivalents is Na2CO3 going to be? NaOH was 1. How many is Na2CO3 going to be? Not a trick question. Just, again, part of the process is to see these things in patterns, and then you won't forget them. So I see a bunch of you are typing in 2, and you would be absolutely right. It's 2, right? So what we got here is we say, all right, it's 1 mole of Na2CO3 gives me 2 equivalents. So really it's 53 grams per equivalent, right? The equivalency is 53 grams per equivalent. Normality takes it 1 step further. We're not looking at weight per se. We're looking at just the moles. So here, normality is the equivalence per liter is really the way to think about it. So you usually got things as moles per liter, that's your molarity, and then you have your equivalence per mole. So you look at this and say, okay, H2SO4, if I have 10 to the minus 1 moles per liter, and it's 2 equivalents of acid for every 1 mole, then really I have 2 times 10 to the negative 1 equivalents per liter. So here's how you would talk this out. If I came to you and I said, I have 1 molar H2SO4, how many normal H2SO4 do I have? What would you say to me? If I said I got 1 molar H2SO4, you'd say, Petros, you've actually got this many normal of H2SO4. And this is not a trick question. I see a bunch of 2s coming in, and you would be absolutely right? So it's 2. So it's 2 normal on the H2SO4. So on that note, let's go ahead and try out question number 5. I'll give you guys a minute. So we're going to challenge you on this one and give you a minute. Don't get caught up in too many of the fine details. Notice that there are words in the answer choices, not numbers in the answer choices. So take a moment and try this one out. Good luck. It's got a gold star. That's our goal here. All right, so I'm seeing about 46% of you, we'll call it 50% of you, are choosing answer choice D. Looks like B is coming in at second place, around 35%, and then A, very sadly, is in third place at 17%. So we got 49 grams of phosphoric acid, and it's got a molecular weight of 98 grams per mole. It's dissolved in 100 milliliters. Another solution is prepared by dissolving 36 grams of hydrochloric acid, which got a molecular weight of 36 grams per mole in 100 milliliters of water. Which solution has the greater concentration of protons? So you do have to do a little bit of math, sadly, right? You got words in the answer is we got to do a little bit of math. So phosphoric acid is H3PO4. Now notice they didn't give you the formula up here for phosphoric acid. They just said phosphoric acid. So you got to know that it's H3PO4. It's a triprotic. It's got 3 equivalents of protons. So if you were to do the math, so you'd say, okay, I got 49 grams out of 98 grams per mole. So I really have half a mole, right? I've got half a mole of my phosphoric acid. And I'm throwing that into 0.1 liters. So, and it's a 3 equivalents per mole. So 49 times 3 divided by 98 times 0.1 is really what you're doing. So 49 and the 98, this of course becomes a 2 in the denominator. We've got the 3 in the numerator. 2 times the 0.1 is going to give us 0.2. 3 divided by that value is going to give us, of course, 15, right? So it's like saying we've got 15 normal of the phosphoric acid. The hydrochloric acid, a little easier. It's a monoprotic. It's 36 grams, 1 mole per 36 grams, times 1 divided by the 0.3. It's 1 equivalent per mole. So whatever the molarity is what the normality is going to be. And so what you end up with is a 10 normal concentration here. So the phosphoric acid is going to have the greater concentration of protons. It's going to be at 15 because it has a greater normality. Okay, very, very specific. It is not a greater molarity. In fact, this has, technically speaking, a lower molarity. But when we look at this, we say, okay, we don't care about molarity, we care about normality. So here's a fun top tip with a question like this. Since they're testing you about normality, you could eliminate answer choices A and C right from the get-go. There's no reason even to choose those because that's not what matters when you're looking at the protons specifically, right? Because you're looking at these equivalents is what you care about. So be mindful of that. Sometimes the MCAT will give you, right? It will give you those bits that you have to kind of pick up on along the way and make sure that you're not messing those bits up, as it were. All right. So that was great. I'll give you a star. I'm not going to give you a gold star. I don't know if we've earned the gold star. I'll give you a green star though because those are fun. Let's take a look at question number 6. Good old arsenic. Also something to be very, very careful about. Not cyanide is not the only poisonous substance that we're looking at here today. So let's look at arsenic acid. I'll give you a minute. Try this one out, and let's see how we do. Let's end this one with a bang. I have full confidence we're gonna end this one with a bang. So let's see how it goes. All right. So this one, Good one for us. Here we go. I don't have my camera. There it is. There it is. So we look at this one here and we say, all right, we've got arsenic acid, H3ASO4. What's the gram equivalent weight? So it's a triprotic. You have 3 equivalents of protons, right? 3 equivalents of protons because it's a triprotic. Gram equivalent weight is going to be 141.1 grams per mole. They gave us that information ahead of time, right? This was told to us in the question. And we have 1 mole for every 3 equivalents. So it's going to be 141.9 divided by 3. Now, here's the good news. You don't need to do 141.9 divided by 3. You could do 150 divided by 3. And that would give you 50 gram equivalents. And if you did that, you would gravitate towards answer choice C. But what you have to remind yourself of is that you had rounded up as far as that 141.9. So you say, okay, I rounded up to 150, which is how I got 50. So my answer needs to be less than 50. And the answer choice that is less than 50 is 47.3. And that's the one that you would choose. If you chose answer choice A at 42.1, multiply that by 3, give you about 126, which is not enough, right? Because you start out with 141. So you do a little back solving on that one as well. Looks like 80% of you chose answer choice B, which makes me very happy, namely because that also means not only did you get the question right, and now this all has come to kind of full circle for you, you get a gold star to end things off. So very, very nicely done. Give yourself a round of applause on that. So what we looked at here today really was the beginning of acids and bases. We talked about determining acid and base strength. Just remember these things. Remember the strong acid, strong base list. Remember that strong acid, strong base, respectively, have larger Ka values. Gram equivalency and normality all comes back to molar mass times the number of moles that you have of reacting equivalent. And then, of course, normality is the equivalence per liter. So the equivalence of acid or of base per liter that you have versus molarity, which is the number of moles that you have per liter. So with that said, big round of applause to all of you. Big round of applause to Ashwarya and Allison and Dee and Henry and Mackenzie, who've been manning your questions as we go. But if you have questions about this stuff, do let us know. But I wanted to kind of close it out with this. I'm going to hand this back over to Ali here in a second. The MCAT, it's a tough exam, right? There's nothing easy about it per se. But the good news is, and you can go brag about this to your friends, as hard of an exam as it is, it's actually the most predictable of all the exams that are out there. So, with the right kind of study plan, with the right resources, with the right kind of customization and personalization, which is something that we've, really thrived ourselves on here at Kaplan. I mean, Dee and I had the opportunity to work on our new program when this test had changed a couple of years ago, now 3 or 4 years ago. Really what we did at that time, and we continue to do, is what you'll see in our program is full personalization. And, it's all about what you as an individual need. I'll leave you with this advice. As you're preparing for this exam, do what is right for you. Because at the end of the day, you are the one that's going in there to take the test. So don't look at your friends and say, oh, my friend, she did this, I'm going to do that too. If it's the right thing for you to do, then go do that. But make sure that the choices that you're making as you're preparing for this exam are the right choices for what areas you need to focus on, content-wise, question-wise, how you're practicing, when you're practicing, and doing all the things that you're doing. So with that said, thank you to each and every one of you. I'll stick around for a little bit here, but I'm going to hand this back over to Ali, and she'll close us out with a little bit of coaching.
For a minute. Hey, how'd it go? I know you guys were loving it. I had to put my sweater on. It's kind of cold here. I know you guys were loving it. And this is why you study MCAT prep and MCAT materials and not just Science. Can anyone tell me something that you learned today in Teacher Petros's class that you learned differently or never heard before or had a more convoluted method in your science class that you can now do easier, quicker, and more confidently? Please, a little bit of practice of what we did tonight. Give me a list. What are those takeaways? You know that's my favorite part. Hi, Sophia. Thanks. Yes, Sarah. I feel like that's the star of this lesson, don't you think? But Joel, that's awesome. Joel says that he needs to review GenChem, but listen, that's what I was talking about earlier, wasn't it? Let the MCAT prep lead the way and tell you what science content it is you need to go back over while you're doing your MCAT. Normality. Elise, awesome. You know, it's been a while, right? It's been a minute. It's going so fast. Quickly and easily going from H to BH and vice versa. That really is such a cool trick. I really like that. I feel like that is the thing, especially in this lesson, that makes me think like, you know what? This is the difference between being ready for the MCAT and everything that I learned in my class in undergrad. This is the difference here, because everything that we do in MCAT prep is designed to get points quickly and accurately. It's not about displaying your science prowess per se. It's about what is the most efficient way to get points. We just want to scoop up points. It's not that I don't care if you guys are science geniuses. I want you all to do great in med school. I so do. But my one and only job, and Petros' one and only job, and Kaplan's one and only job is to make sure that you guys get enough points in the time frame that you take your test that you will go to medical school. That's it. We just care about points fast. We do, Rat, don't we, Yvonne? I'm going to say it. I love it. So let's talk about study planning. So I did say that we were going to talk about building your MCAT calendar. Who knows how many hours on average people will spend preparing for the MCAT? What do you guys think? What do you think is the average amount that your competitors are spending preparing for the MCAT? Kayla, I love it. There you go. Nicole, the other way. Flip those numbers. That's a lot. That's a real high. Yeah, I'm going to put it right at 300. It could be as high as 350. And I think 300 to 350 is like a good range. So maybe we call it 325, right? That's a lot of hours. That's a whole lot of hours. And that's average. That means that there are people who need to spend a lot more. So what you have to do, and you guys know that I love this topic, is you have to be very cognizant about your study planning, because you don't want to end up being the person who's on the far end of the outliers of that particular, because 300 to 350 hours, that's a lot of hours, and that's just average. So you don't want to be way an outlier on the far side of that. It's going to be a problem. So one of the things that you need to do is really be very cognizant with your study planning. Let's talk now about your MCAT calendar. So here I have a sample MCAT calendar. I see calendars like this come all the time. Fun fact, I have my students submit to me what they think they're going to do, and then we work backwards from there. What is wrong with this calendar? It does have a flaw. Who sees it? What do you think is wrong with this calendar? Could be a couple things, but what do you think is the main thing? That's average, Joel's. Absolutely. That is average. It's a lot of material that you have to go back over, and it's a very important test. And the largest majority of people who get accepted are on their first time taking the test. That's not to say that taking it a second time, you won't get in. It's just to say that competition is very, very tough. Right. There's no breaks. There's zero breaks. It's just day after day after day after day after day after day after day. You're not going to do that. You're not going to do that. And even if you did, you don't want to. You will burn out. Absolutely. And besides burnout, you will not retain information as well as someone who takes breaks. Let me show you what the data shows us. I love that. Let me show you. So here You can see that if you don't take immediate breaks, that your retention right at the very beginning, like immediately, maybe your retention is slightly higher, but over time, your long-term retention is greatly enhanced by taking breaks. Your brain needs time to process what it is learning. And your brain actually has ways to protect itself. Like it really will. Have you guys ever studied so much that you are no longer retaining at all? And your brain is just like you're having to reread and reread and just like nothing is sticking. Like everything is just like it in the eyeballs and right out the ears. Has anybody ever studied that much straight? That is your brain like, no, we're taking a break. We need a break to process all of this if you want us to hold on to it, right? And you have to make sure that you do that, right? And so, sometimes people say to me, oh, no, I'm a beast. I'm going to do every single day MCAT. And I'm like, no, no, no. This is not about your beast status. I believe you're a beast. This is about retention. This is about long-term retention of material and learning science. And learning science tells us that if you take breaks, you will you will retain more information for longer periods of time. So not is it about burning, it's not only just about avoiding burnout, which is huge as well, because I think most of us will burn out with no breaks, but it's also about increasing retention. So you need to have breaks. You need to have breaks. Let's talk about flaw number 2. What do you think is wrong with this? We've now got our day off. We're taking Sundays off. We're like, Sunday is rest day, Sunday fun day. What is wrong with this calendar? What now? We have our blocks of MCAT study. Here is where I do a block of MCAT study. What could be wrong with that? What do you think? What is that? I like to see that. I'm glad that the student has decided to start going to classes, though. That's great. It's not even just no practice and no review. What is it? We don't even know what that block of MCAT study is. Is it a test? Is it a class? Is it a chapter? Yes, Courtney, it is not specific. We don't know what that means. Have you ever said, okay, I'm going to set this whole day aside for MCAT, but then you didn't really decide ahead of time what you were going to do? So you just kind of ended up like a little bit of this, a little bit of that, trying to figure out what to do, and you end up maybe wasting more time than is valuable because you just like, it's MCAT time, but that could mean anything. There's so many sciences, there's so many question types, there's so many resources you could be using during science time, right? This is something that was really hard for me to learn actually, because I did not actually I'm not a super organized person by nature. I had to really learn everything about MCAT prep, and especially the organization feature of it. You've got to be specific. You have to say, this is what I'm going to work on. This is how I'm going to work on it. Otherwise, you could end up burning up a lot of your time just in like, gosh, what do I do next? I guess I read a book. I guess I. And then also, you're not going to be learning at the clip that you would like to be learning at because you're not taking the time to be cognizant of what are my proportions. I had some students who were messaging me and were saying, and I actually get this a lot, so you can tell me if this is you. I've been studying for a long time. I feel like I understand the test. I feel like I understand the methods to approach. I feel like I understand the science, but when I take the practice test, I'm not getting the scores that I want. I'm not getting score increase. And they tell me that they're putting most of their prep time into instruction, reading chapters, going to lessons, working with their tutor, and then every so often they take a practice test, right? The problem here is that there's not enough practice, discrete practice coming in between that you should expect to see any difference. Like if you weight all of your study to instruction and very little to practice, I mean, what good is instruction without practice? This is an application-based test. The same goes in reverse. What good is all of your application if you have not learned something new, right? You need both. And so when you have this very unspecific block of time, what ends up happening is you are no longer in control of what your proportion is. My proportion of practice to instruction. I don't know what that is. Could be anything. I don't even know how much I'm studying Gen Chem versus, biology. I don't know because I'm just doing whatever happens on that day. So you have to be a lot more specific, and it really is important. Let's check out how we can do that. All right. So here the student is now getting a lot more specific. The student is saying, all right, I am studying biochem. I'm having my biochem class on Tuesday. Notice Monday's schedule. Do you guys see how does Monday's schedule relate to Tuesday's schedule? Because student did it again between Wednesday and Thursday's class. What does it look like this student is preparing to do? Because I think that this is very specific, and they've done this for a reason. They've organized the relationship between Monday and Tuesday and Wednesday and Thursday very specifically and purposefully, which is great. They're preparing for their classes. That's right, Carol, absolutely. They're like, this is the material I need to know for class, because you know what? An MCAT class on biochem is not an undergrad science lesson on biochem. It is a bunch of MCAT practice problems and preparing for the MCAT using our biochem knowledge. So we'll go back over the science in class, but we don't reteach it in its entirety. So you want to be ready for it. So they're like, hey, let me make sure that I've read this stuff, that I've taken a little chapter quiz to make sure that I've understood this stuff. They're basically preparing all of their content so that they can then be ready and strong on content the next day and do application in the class format. So I think this is really awesome. And then if you look at Friday, and you look at, if you look at Friday, they're doing a bunch of QBank work. So they're just practice individual. They're targeting stuff in their QBank. So that's what they learned that week and they've been working on. And they're doing that with discrete questions. And I see they're doing it with passage-based questions as well. And then Saturday, they say, you know what, I'm gonna take a diagnostic test today. I feel like I've learned a lot this week. Let me see what's going on. And they're gonna hit up in the evening with stuff preparing for the next week. Right, and doing their flashcards, their quick hit type stuff. So I like this a lot better, but it still has a flaw. What is the flaw here? I'm glad to hear it, Becca, and it's true. This advice will work for any major test at all, but it just is so important because test prep is really different than regular study. I see so much open space. I'm just gonna relax all day. I'm just gonna lay by the pool, and in the evening, I'm gonna do all my MCAT stuff. Well, now listen, you're gonna get 300 to 350 hours and on average in however many couple months or a month that you plan for yourself. I know some of y'all tried that. That is next to impossible. Tell me this, do you guys have all this pool time in your calendar? Do you guys have like all day Monday to just like chill out and hit up MCAT in the evening? So like MCAT is all you have in your life? Yeah, Becca, absolutely. What about daily activities? What about classes? What about chores? This is still a highly unrealistic schedule because it looks pretty doable, except maybe Saturday is a little tough. But exactly, Meg, what is pool time? But it looks pretty doable because you're like, you know what? Yeah, I could do this, okay, I can see it. Right, but you have nothing else in your life there going on. I wish, Carol, I wish. But so many of us are in class, or we're shadowing, we're doing volunteer work, or we have actual jobs, right? We have families. We also have things that make us us, right? Going to the gym. I can't miss my gym time. I cannot. I will be a hot mess of a person to deal with. Like not only will I not be retaining what I'm learning very well in my studies, but I'm also just not going to be very pleasant to be around. There are just things in my life that I need in order to be a happy, healthy, and retentive person. So you have to build in your real life. When you build your MCAT calendar, this is how I want you to do it. I want you to start with about 28 hours of professional. I'm assuming that most of us are doing about 28 hours of professional stuff between going to classes, volunteering, shadowing, actually working, all of those things, right? So we'll say up to. We're going to have 20 hours of personal stuff. This could be your gym time. It could be if you have social clubs that you do, hanging out with your friends, if you do a Sunday night dinner with your parents, whatever are those things that you do with yourself. And then you need to build in your 20 to 25 hours of MCAT prep. So it should look like this. You start with the things you know you're going to be doing. So here's your work stuff. Here's your college classes, right? Notice that this is all professional stuff. And then your MCAT classes, like whatever actual classes you're doing for MCAT, that's what you start with. So build that into your calendar first. Then build in the personal things that you need to make you. Like, see my gym time? It is definitely represented, right? Things that I know that I'm going to do, like, because you have to, for retention, to avoid burnout, to be who you are. Like, you have to not only break, but you have to, like, see your friends, see your family, whatever it is. So build that stuff in next. And then is your practice and your homework and your review and your specificity. Do you guys see the difference between this calendar and the ones that we did before? I want you to screenshot this so that you can use it as kind of like a map for what you'll be doing. And listen, yeah, you're going to be busy. I can't lie to you. If you're doing MCAT prep correctly, you will be very busy. But yeah, Teacher Ashwara is absolutely right. You have to be 100% super honest with yourself, because you need to ask yourself too if your time frame is correct. And you guys can always email me with your information, but you have a lot of hours to fit in. You have a lot of work to do if you want to see significant score increases. You also have other obligations going on. So you just want to see how much you can do. It is busy and it is realistic, Becky. It is, Becca. It totally is. But I think it's doable too. Like, we're breaking up the tasks that we're doing. We are being very specific. We've built in the order of importance, which is we started with our work and our school, including MCAT classes. And then we came in with the things that we need to be happy, successful humans. And then we came in with all the practice and the review that is just so, so important. And yeah, it's really busy, but I want you to really think about what it's going to be like in medical school and what it will be like after that in your residency, when you legitimately have shifts that are 24 hours long regularly, like working for 24 straight hours. That's a thing, a real life thing that you have decided you want to do in the pretty near future. So let this be your first little taste of it. But you know, it's going to be a busy time. It is, but nothing is worse than packing in the hours and being as busy, but not getting as many points because it's just however many hours it is. Yeah, we still have Sunday is the day off, Kyle. Check out the activities on Sunday. That's just day off activities. We're going to the beach. We're going to dinner with mom and dad. We're having movie night. So that's our day off of our MCAT. Right? It's not a day off of life. We're not going to just like cocoon ourselves. I mean, we could. I'm a big fan of cocooning myself. But that's what I have for you in terms of study calendaring tonight. Make sure that you have entered your email in the poll. We're going to do our, send out our handouts and our homeworks and all of those things. We're going to answer and give you all of the advice that you need so that you can be ready for the next day's class. Everyone got their email in there? And I want to talk to you too about making sure that you are sending in those questions. They can be about anything, but the questions that are going to be easiest are going to be about resource utilization, study planning, questions that come from Kaplan MCAT sources. So if you took a Kaplan MCAT practice test, if it's something from a lesson that we've done or whatever, but you can feel free to send whatever you want. And I want to thank you guys so much for joining us. You know, we love to do this. This is honestly what we love to do, and we don't get to do it. Like, we always say we don't get to live our dreams unless you allow us to help you to live yours. And that's 100% true. We're just so, so thrilled to be a part of your test prep journey. We're so happy to have you as our students. We look forward to working with you all week. Make sure your email is in my poll and that you reach out to me and my team. We're very happy to help you and advise you as best that we can. And we're here for you all week long as part of Kaplan's free week of MCAT prep. Talk to you soon. Bye-bye.